My name is Mance Harmon. I'm a co-founder of Hedera Hashgraph, which is a large layer 1 network that you perhaps have heard of. And most recently, the co-CEO of Swirlds Labs. Just a bit on that because it's kind of confusing for people that have some experience with Hedera. Hedera recently decentralized operations, and the team that built Hedera is now in Swirlds Labs, and the office of CEO and CTO at Hedera have been dissolved. So Hedera is now a network. I'm going to talk about it, a governing body. There's a governance structure in place, and you know, in some ways it's a standards body as well for the technology and the platform. So Hedera is the network. Swirlds Labs is the organization that builds the software, and those that built Hedera are now in Swirlds Labs. That's the short version of this. So let's, the focus of the talk today obviously is ESG. And I think a good place to start is just by defining what we mean when we say ESG. So the acronym stands for Environmental, Social, and Governance, and it really deals with the focus of organizations on their impact on society and the environment, the planet. And it deals primarily with the processes and practices within an organization for measuring and controlling that impact. What we're going to talk about here is how that relates to distributed ledger technology, specifically to Hedera in this case, and how a layer 1 protocol can help in solving some of these problems. Whoops, let me go back. So when we talk about layer 1s, just a bit about layer 1s and the focus of Hedera specifically. When we started Hedera we started in 2017, introduced the world to Hedera in 2018. There were a set of specific problems that we felt we needed to address in order to see a layer 1 scale up for mass adoption. And these are those, and they haven't changed since then. Originally, of course, proof of work presented all kinds of problems. We all know what's just happened with Ethereum and the reasons for their moving away from proof of work to proof of stake, enormous amounts of energy, low processing speeds. The layer 1s today are far better than what they were. Ethereum has received a boost in terms of TPS versus what it could do in proof of work. High unpredictable processing costs, that's directly related to the processing speeds. If you can process more transactions per second for a given unit of energy usage, then you can charge a lower cost for the same transaction. But you also need to be able to charge or denominate those charges in dollars rather than in the protocol token. I mean, that's still a problem for nearly all layer 1s out there today. You have their tokens, you want to use the network, but the cost to use the network fluctuates with the cost of the token. Hedera doesn't do that. Hedera denominates its transactions in dollars rather than HBAR. And then security vulnerabilities. The layer 1s, by and large, still have some serious security vulnerabilities. Most of them are leader-based. We can talk about that if there's interest, but basically what it means is that they're susceptible to distributed denial of service attacks, and we continue to see this, especially with some of the larger protocols. Everyone knows the problems that have happened in the past 6-9 months with Solana, for example, and DDoS attacks, whether they're intentional or not. And then centralization and transparency concerns associated. What I'm referring to here specifically is if it's the case that you allow anonymity in the operation of the network, then you really don't know who is controlling the network. Anonymous nodes can be represented by a single bad actor. If a single bad actor can control enough of the stake or the hashing power, then they can cause problems for the network. You don't have transparency in what's actually going on behind the network. So how did we address these things? First, We have fantastic performance. It's because we don't use a blockchain, quote, quote. We use something called Hashgraph. I'll just talk briefly about that in a moment. Today, the network has capacity to process 10,000 transactions per second, and that's throttled. And that's in a single shard. So we will scale through sharding and releasing that throttle to millions of transactions per second as demand requires. And then, of course, finality within seconds. What this means is when you submit a transaction to the network, you want to know that it's never going to change with 100% certainty within a few seconds, if possible. I mean, that's what the credit card companies require at their point-of-sale systems. In fact, if you swipe your card or use a chip these days, then that transaction has to be final within 7 seconds by standard. And we achieve that with the technology. If you're proof of work, by the way, you never achieve that because it's probabilistic finality. You never actually get to 100% certainty that it's never going to change. Security. This goes back to what I was commenting on earlier. The theoretical limit in terms of what can be achieved in security is something called asynchronous Byzantine fault tolerance. What that means is that there are no simplifying assumptions about a would-be attacker. Let me make that more concrete. If you're just BFT, Byzantine fault tolerant, which a lot of the layer ones today are, proof of work is not, by the way. If you're proof of work blockchain, you're not even BFT. But if you're one of the layer ones that is proof of stake, it's often the case that they are BFT, but they're not a BFT, which means there is a node that is responsible for coordinating the communications to all the other nodes. Well, that node is a leader and can be attacked with a denial of service attack and bring down the whole network. This is what we've seen on occasion with some of the layer ones recently. And it's a really hard problem to solve. If you have any kind of coordination like that, you have a natural target. And by the way, in those other layer ones, you know who is going to be the leader for an hour in advance. So if you want to change the leader, if the leader gets attacked and they decide to change the leader, you just change the target of the attack and you keep the network down. This is a fundamental problem in the architecture that has to be addressed. Hedera fundamentally addresses it in that there is no leader. All the nodes are exactly the same in their function. So that whole category of potential problems just goes away. And that's what we mean by saying reaching the theoretical limit of what's possible. It's been known for 30 years. It's called asynchronous Byzantine fault tolerance. The challenge, by the way, well, I'll come back to it. Stability. I've already talked about this briefly. For developers that are building applications, they care about what their cost of goods are going to be. They have to be predictable. If you want to build a business and you have components or parts of your product that you have to account for the cost of, if that cost fluctuates wildly, like the crypto market does, then that's a real problem. And so what we've done is we denominate the cost of the transactions in dollars so that the developers know what their costs are going to be, irrespective of what the cost of HBAR is. When they build their application and they're preparing to make API calls, the SDK that they've used for building that application figures out how many HBAR is required at a moment in time for the API call, and then just uses the right number of HBAR. Governance. Governance is a big deal in decentralization. And what we're referring to here in governance is, who is it? What body of entities is making decisions about the protocol, the product roadmap of the protocol, the legal and regulatory posture of the protocol, the use of treasury for the protocol? All of these real-world decisions that have to be made about the platform has to be governed by somebody, and you want to make sure that that governance is both transparent in who is making those decisions and that it stays decentralized. We've got Ethereum. Of course, the big news with Ethereum was that after the merge, there were 2 addresses that represented almost 47% of the stake in the protocol, which is a real problem. So how do you ensure that it stays decentralized? And then finally, sustainability. And this is going to be an increasing problem. That's what we're here to talk about today. The SEC recently proposed a rule change that would require public companies, when reporting on their their products and services, would require them to report their carbon footprint. And ultimately, not just what they use in terms of energy, but what their upstream supply chain uses in terms of energy consumption. That's a huge deal. If it passes, it's going to change everything, right? And so you have to be concerned, if you're developing a product and you're using a layer 1, you have to be concerned about the carbon consumption, the energy consumption of the layer 1, because you're ultimately going to roll that into your own reporting for your products and services. So you want to go with a layer 1 that has a low carbon footprint. So I've talked a little bit about Hashgraph. How do we do all this, by the way? So why is it that Hedera is able to have the performance simultaneously with the security, achieving the theoretical limit in terms of security and really low carbon footprint? It has everything to do with this algorithm, this consensus algorithm that's called Hashgraph. And I'm not going to go deep into this now, but in short, conceptually, to help sort of build a mental model of how this works, rather than there being a chain of blocks of transactions, each node in the network having a local copy of that chain, the transactions flow into the network, and all the nodes in the network receive those transactions simultaneously. They sort of pile up on each other, and then we're able to, through some magic of math, able to sort of sort and order those transactions in a way where we all agree on their order. But, definitionally, that's what it means to have distributed consensus. Again, not going into how this works. I'm happy to afterwards if anyone's interested. But we're able to do it with incredible efficiency. Lehman Baird is the one that invented this tech. He's my co-founder. And this was the problem, the fundamental problem that he was attempting to solve starting back in 2012. How do you achieve ABFT while also achieving the limits in terms of performance? If you can solve that problem, then you sort of get for free energy efficiency. And as a result of that, as a result of solving that problem, we have fantastic energy efficiency. And I'll go into that a little more as well. So what are we as a platform? We have the network itself. So we have Hashgraph consensus. These are the nodes. They're run by the node operators. And then on top of the Hashgraph consensus algorithm, we have several services that are needed by developers just to build their applications. We have something called the consensus service. Think of that like Hashgraph as a service, or, quote, blockchain as a service. So if you just have a blob of information, you submit it to the network with a hashtag on it, and then you have your software, your clients, wherever they are, in smartphones or computers, they're all creating transactions and submitting them to the network with that same hashtag. Then our network takes all of those transactions, puts them into a consensus order, and streams them back out to you, the developer, to use in your application however you want. You could build a private network that has privacy and scalability and low cost, and sort of outsource your consensus, if you will, to us, Hashgraph. In fact, we do exactly that. We have a plugin to Hyperledger and Corda, for example. So you can scale those private enterprise applications using our network for the consensus at a really low cost with the best performance and security, while still maintaining your privacy and data integrity in a private network, which you can't completely get if you're using smart contracts on a public network. But we also have those, right? We have smart contract service. It's the EVM, and it has fantastic performance, even relative to Ethereum. So you can use an EVM with Solidity if that's of interest. And then we have the tokenization service that makes it possible to mint and manage tokens, arbitrary tokens, anything you can imagine. And then, of course, all the applications get built on top of that. And we address a lot of different applications today. So the G, let me see something. Yeah. The G in ESG stands for governance. And we have taken governance very seriously from the day that we created the Hashgraph algorithm. And this makes us unique in the industry. In fact, it was the case that Libra attempted the same sort of governance model before they got shut down, and we like to think that they took it from us. So the way that we address governance is inspired by Visa. You know, back in the 60s, when Visa wasn't Visa, it was called Bank AmeriCard, there was a gentleman named D. Hawk that he was the founder of what we know today as Visa. He wrote a book about that experience, and he outlined the governance model that he used way back then to bring together a group of organizations that were all competing with each other to create the network in collaboration with one another with trust. And that's the foundation for what we did. What it looks like for us is a global council of blue chip organizations that are the governing body of Hedera. These are their logos. So this gives you a sense of who Hedera is. Each member of the council gets one vote in governance. So it's the case that the members are specifically chosen to be cross-industry. It's not a bunch of banks or a bunch of tech giants, lots of different verticals represented by this governing council, and to also be global. It's not US-centric or Europe-centric or Asia-centric, but be global in their representation. And finally, they're term limited. They can't stay a member of the council forever. They can serve up to 2-3-year terms before they have to rotate off. So through this process and design, we're growing. We're at 26 today. We're growing to 39. And this is the governing body. And they manage all the things that I talked about. They do treasury management. They operate the mainnet. And they have decisions and voting on the product roadmap, as well as the community input. And from here, we're adding community nodes and then ultimately anonymous nodes. But this is where we started. Think of it, by the way, just think of it as a DAO. It operates as a DAO. We actually created it before DAO was a thing. And if you look at DAO, the rules for DAOs, especially in the Wyoming law, it's based on LLC law. And this is a Delaware-based LLC that has its bylaws to enable what was one of the first DAOs. So think of it as a DAO. So the E in ESG is all about the environment. And as I've already mentioned, we're very efficient when it comes to energy consumption. The council has ensured that we're going to stay carbon negative. To give you a sense, for the mainnet that runs all the dApps, we're so efficient that it only costs $250 a quarter to be carbon negative for the mainnet. And let's talk a little bit more about that. So how can you use, actually I'll come back to that. How can you use Hedera or any DLT to solve some of the fundamental problems associated with the ESG market? The problem is this. It's really easy for an enterprise or an organization to claim that they are carbon neutral or carbon negative, or just to claim generally that they are green. The problem is it's really hard to verify those claims. And the reason it's hard is that when offsets or tokens, if you will, are being created that represent the offsets that might be purchased by an organization to offset their carbon footprint, the quality of those offsets varies greatly, and it depends on the type of offset that gets created. These are the different categories of ways in which you might claim that you're green. So if you're using renewable energy, then you can buy certificates that will represent a certain amount of carbon footprint. And that represents about 34% of the ESG market today. Avoidable deforestation, 32%. Way down here, carbon removable or removing technologies, almost 0%, but they're the ones that actually are the most valuable because you know exactly how much carbon you've pulled out of the atmosphere, and you can have that certified and know for certain that it is what you claim it is. The problem is that if I claim that I have created a credit or purchased a credit that's associated, for example, with avoidable deforestation, I've said I'm not going to cut down a forest, and therefore I deserve a credit, and then you use these credits. Well, it doesn't really count. In fact, it's fraud if that forest was not going to be cut down anyway. Right? You have to actually have a net improvement in what the expected carbon footprint or consumption is going to be. And that's where the challenge comes into play. So we can use DLTs to help address this problem. And the way that we do so is by recording the specific information that's used when capturing those the information related to those certificates, those renewable energy certificates or the offsets that ultimately are the basis for the tokens that get created in the first place. You can capture all of that in a principled way on the information associated with that on the DLT that then provides both immutability and transparency, which gives you auditability. And if a company is buying the associated tokens or certificates, then there is public scrutiny on the quality of that information, right? And all of that is important. So we can do that, and we do actually do that today. So UCL, University College London, is one of our council members. They decided that they wanted to do an analysis of the market and try to understand which layer ones were actually, quote, green, and to what degree were they green. They've done this work, they wrote the report, you can go and get it, but what they found is that Hedera by far is the greenest or uses the least amount of energy of any of the layer ones, and this is what that looks like. So if you just look here, let's look at Ethereum, and they analyzed Ethereum 2.0, the proof of stake Ethereum, obviously, not proof of work. And the rest of these here are proof of stake systems as well. For Ethereum, in its new form, Hedera uses 9,000 times less energy than Ethereum does. Maybe even more important than that, look at Visa. The Visa network, it takes 70 transactions on the Hedera network to use the same amount of energy as one swipe of your Visa card. That gives you a sense of how fundamentally green the Hashgraph consensus algorithm is and why we've given so much focus to this sector. Okay, switching from environmental to social, because E, N, S, and G are all important. When Lehman, the inventor of Hashgraph, started down this path in 2012, what he wanted to do fundamentally was address a problem in Web 2.0. And we're all familiar with this, right? The Web 2.0 problem is that our information, our privacy in our data is not owned by us in the way that we'd like for it, and certainly not controlled by us in the way that we'd like for it to be. And so moving away from Web 2.0 centralized architectures to a Web 3.0 decentralized architecture was the whole point when we started this in 2012. The vision, the original vision, was to enable people to sort of reach out and grab a slice of cyberspace and then to run their programs, their games, their business applications, their social applications in this private environment in which they invite their friends and family and colleagues to participate without having to trust a single central organization for the coordination of all that information or for storing the database that's associated with that information. Truly decentralized in a very fundamental way. That's what Hashgraph was all about. That's what we've built to start in a layer 1 public protocol as a foundation for ultimately realizing this vision, including social, which is sort of the next step down this path. So let's talk briefly about some use cases. DLA Piper is one of the leading global law firms. ServiceNow is also a global organization. ServiceNow has a market cap of, I don't know, 100 billion plus. Huge organization. And what they're doing is DLA Piper has created a platform called Toko that makes it possible to tokenize anything. They started with the idea of tokenizing real estate, but they are also involved in tokenizing assets, in this case associated with workflows that customers of ServiceNow have and use ServiceNow for, and capturing the measurements of how much carbon is being used in their workflows, and then either tokenizing the tokens that represent those emissions, or it could be tokenizing the workflows that lead to carbon credits, either one, right? And all of this is being embedded in what is the back office applications of enterprises, right? So that's just one example. LG just announced this. In fact, I think it just went live yesterday. LG is another council member of Hedera. They now have the ability on their TVs to purchase NFTs. And the reason it matters to an organization like LG to be on top of Hedera goes back to the tracking and measurement of the carbon usage through your supply chain. And by using us, they actually get a credit. We're carbon negative, and so it benefits them from a carbon perspective. And you can now do this today. If you're in the United States, you can, and you have an LG TV that runs WebOS, you can download the update and go through a process and buy NFTs through their marketplace and demonstrate, or present them on your TV. Standard Bank, another council member out of Africa, one of the largest banks in Africa, is in the process of building what they're calling a digital green bond platform. Makes it possible for financial institutions and others to go to market with tokenized financial assets that opens up the pool of participants and makes it possible for those investors to invest in projects that are concerned with, that have an environmental and climate impact. That's why they're calling it the Green Bond Fund. Avery Dennison. Avery Dennison, another council member, big enterprise in material science and manufacturing. They have a platform called atma.io that tracks widgets through a supply chain. Their customers manufacture all kinds of things. Adidas, as an example, manufactures sneakers. It's just one example. And from the moment that the raw materials come in to the manufacturing process to the point where they get sold through distribution out to the consumers, those products get an identity that gets tracked in the atma.io platform. The carbon consumption of the process of manufacturing can be tracked, and then the purchase of the offsets can be done as well through this whole process. They're tracking tens of billions of items in the atma.io platform today, and their integration with Hedera is done, and that traffic is about to go live. It's imminent. I don't know exactly when, but it's within weeks is the expectation. What that will mean is that for the first time, a layer 1 protocol is going to be processing billions and billions of transactions per year, unlike anything else that we've seen in the market so far. That's with one user, one application. Okay. ServiceNow, I've already talked about it. They're doing other things outside of what they're doing with Toko. but implementing the ability for their customer base to take advantage of the technology that they've integrated into the Now platform. The Guardian. So Guardian is a tool set that's been built. It's being used by hundreds of folks, hundreds of entities today. It makes it possible to build policies associated with the measurement, reporting, and validation, or excuse me, verification of the information that is used during the creation of these carbon credits and offsets. All of that information has to get reported ultimately because of the new SEC rules. This tool makes it possible for organizations to automate that so that they can do the kind of reporting we anticipate is going to come from regulatory action. HALA systems, and then I'll be brief. So HALA systems, moving over from the E to the S, the social. HALA systems is a social enterprise that's using our network to make it possible to capture information and demonstrate that it's not been tampered with in the future. And specifically, it's allowing third parties to capture information. For example, if there's an airstrike in a given, well, the applications, one of the specific use cases that they've enabled is in war-torn Syria, and the capturing of information that's happening on the ground in real time, integrated with the siren system so that people have some notice if there are missiles that are coming in or whatever the problem might be, and then capturing it in real time onto the ledger. Starling, another social use case. Starling is doing a similar sort of thing, except they've focused most recently on the Holocaust, capturing Holocaust information before it gets lost forever, as well as the US election. They were on site capturing the Capitol riots on January 6th, and they've also been capturing specific information in the war in Ukraine. And then Timeless and Dovu are a couple of other organizations that are helping build out the infrastructure that makes it possible for larger organizations to implement all of these processes and workflows that I've already described. And they're part of the ecosystem as well. Okay, I think we have 2 minutes left. Happy to take questions if there are any. And if not, then thank you for your attention and enjoy the rest of the conference.
Thank you.